Hey you, what do you think you're doing in my chemistry lab, man? Oh, hey there, bud. I just saw this video camera chilling out here and I, was doing my off-season training, decided to take a little, get some footy for the Rockets in the crowd, you know what I'm saying, bud? Hey, that's cool and all, but, I got a very important chem project due for Miss Staper, so you're gonna have to get out of here, man. Sorry. Hate to be that guy, but you gotta leave. Oh, chemistry, you say, bud. I aced that thing back in my minor league days. Back when I was just on the rise of stick and puck. You know what I'm saying, bud? Why don't you let me take that off your hands? No, I'll do it for you. No charge, no charge. I'll do it, bud. You know what? Fine, just do it. Submit it by the end of the day. And I'm doing it on a water molecule, and I have my... Where'd my model go, man? Where'd it go? Oh, you mean the apple and the two marshmallows, bud? Dripped in like chocolate sauce? Oh yeah, I ate that, man. It looked real good, and it had some like weird toothpick type things. It kind of looked like a water molecule. I ain't gonna lie, it kind of did, bud. But yeah, it tasted really good. You should try some. I guess I ate it all, but you should make it again. Of course you did. Typical hockey players. You know what? It's your lucky day, though. I took a picture of it. Just make sure when you do the experiment, use these safety goggles and protective gloves. Hey there, folks. It's Mr. Dangle Snipe and Sally, and we're back talking about another chemistry video. First off, always wear your safety protection. Let me sauce that on real quick. There we go. Who needs gloves when you got hockey mitts? All right, today we're talking about water. Let's get at her. Well, hey, bud, like water's pretty essential to life. There's a few minor things like you need water to live. Like, your water's made up of like 60 to 70%. Without water, you just die, and your cells need everything. And, plants need to survive on water, and like, they need water to grow. We got animals need the water. We eat the animals. We need that water. But, the most important thing that water is, a part of life, is that, when water gets below 0 degrees Celsius, it freezes. And, that gives us the ice, so we can play the hockey. And without water, we'd have no hockey. Right now it's a coronavirus time, going through some hockey withdrawals, and I couldn't imagine a whole lifetime without hockey. Hey, bud, so, water's essential to life. Well, first up, we have the first topic on the list, the intramolecular bonding that occurs in this molecule. Now, that bonding is polar covalent bonding. A water molecule has polar covalent intramolecular bonds because the atoms have different electronegativities, but the difference is too small to form negative and positive atoms. Like when the atoms are binding, the one wants to steal the electrons from the other, but it can't, so they just form polar covalent bonds. And polar covalent bonds usually occur between non-metal atoms. We like hydrogen and oxygen, which makes up water, H2O. You know what I'm saying? And then non-metals like hydrogen and oxygen do not give up their electrons, but share them, like I was saying before, to obtain the ideal valence electron number when bonding. So like I was saying, like they don't, like if I have an oxygen here and a hydrogen there, the oxygen doesn't steal, they share. That doesn't happen in hockey. We're not nice like that. About to drop the mitts and fight a guy, I'm gonna do that. We don't share in hockey, so like hockey's not like polar covalent bonding. Next up on the show, I'm gonna go to the interesting facts about water, and we'll go to the hotline here. We got a caller. Hello, Fred. You got an interesting fact? Oh, nice. Okay, very interesting, Fred. All right, that was Freddie on the line. Me and him played back together, you know, in like the minor leagues, I think it was. And he says an interesting fact about water is water's chemical formula is H2O is better known than any other compound. And that's very interesting because that's also the reason why I chose this molecule, because, you know, it's the only one I have memorized. I'm just kidding, but I'm not kidding. Thank you. Oh, shoot. Don't mind me, I'm just measuring the appropriate amount of water. Whoa, water for my off-season training here. Whew, perfect. All right, whew. Worked up a good sweat. All right. Next, we got intermolecular forces that occur in the molecule. You know, before we just talked about intramolecular bonding. Now we're going to talk about the intermolecular forces. Whew. I'll be right back. Sorry about that, you know, just a few hockey mamas wanted me to give their kids some autographs, you know. But let's get back to what we were talking about. We were talking about the intermolecular forces that occur in a water molecule. And these intermolecular forces are hydrogen bonding. You know, oxygen is extremely electronegative, which means it likes to hog the electrons. So, you know, what I'm saying is like this produces a partial positive charge at the, you know, the hydrogen end, and a partial negative charge at, like, you know, the oxygen end. So, you know what I'm saying, bud? So when you have two water molecules, the partial negatively charged oxygen ends with the partial negatively charged hydrogen end. You know what I'm saying? That's called hydrogen bonding. And, you know, yeah, that's called a hydrogen bond. Hydrogen bonds gives water its unique characteristics. So, you know, hydrogen bonds are also, you know, they're a bit weaker than covalent bonds within the water molecule. But, you know, that's not important, really. All it's important to ice. You know, water freezes, so we get ice so we can play stick and puck. That's the only thing that matters. You know, speaking of the little stick and puck, today was kind of a sad day for me because, you know, got the backyard ODRA. It's beauty ODR, you know, got some nice boards up there for playing stick and puck with the boys. But, you know, I had to drain that thing today because, you know, it started melting. And, you know, the water's melting point is 0 degrees Celsius. You know, this is due to hydrogen bonding, which makes water have a higher melting point. So, you know, because there's more forces holding the molecules together. And, you know, the boiling point as well of, you know, the H2O is 100 degrees. Can't remember the Celsius or Fahrenheit, you know, let me get back to that. Oh, my bad, that's definitely Celsius. Here we go. Yeah, it's definitely Celsius, 100 degrees Celsius. No, back to what I was saying. Hydrogen bonding, you know, makes water have a higher boiling point than if you just had London dispersion forces. You know what I'm saying? So just another fun fact about water. All these fun facts, you know. Make me want to go to the And we're back to another segment of the show that we call 5 Interesting Facts About Water. And we're going to go to the call line. Hello? Interesting. Alright, thanks, man. Hey, that was Sammy from my current team right now, the Parkland Beauties. And he says, interesting fact about water is that the speed you know, like the speed, like the quickness of light in water is 3/4 of a speed in air. How wild is that? Oh man, you know, that's pretty crazy. You know, you learn something new every day. Thank you, Sammy. Oh man, we got a ton of calls on the line here, so we're gonna go back to the call line, okay? 5 interesting facts about water here. Oh, yep. Oh, thank you, bye. You know, you have a good off season too. Thanks, man. Thanks. That was Jamin on the line there, and he says another interesting fact that has to do with speed. The speed, you know what I'm saying. Like the speed of sound in water is 4.3 times faster than in air at 20 degrees Celsius. Holy man! You know, sound apparently just travels fast in water. You know, like, that's why when you're on the ice, you know, and you're like, holler at your boy for a pass, you know, give me a puck, give me a puck. It comes a bit faster because you know it's water, but like the ice is frozen, but like it comes a bit fast. You know what I'm saying? Oh, on the line again. Whew. Hello? Yep. Oh, interesting, man. Thank you. That there was a scout, you know, who wants to give me a contract. But he also did say that pure water is not able to conduct electricity, but when an ionic compound is dissolved in water, it can. How whack, you know, that's just crazy. You know, what a beauty guy. That guy was an absolute legendary beauty, but like, that's crazy. Oh man. Oh, it's ringing again. Sorry. You know, we're having a bunch of calls in a row here. I'm sorry about that. Are you serious, man? That was my coach. You know, he said I was benched for the next game because, you know, I didn't submit my workout to him. I told him I was making a chemistry video, but like, he doesn't care. But he also did say that water can dissolve more substances than any other liquid, including sulfuric acid. That makes 5 interesting facts about water, and I'm gonna, no, I'm shutting my phone off. They keep calling me. All right, thank you. And he's coming around the net. He takes out the team out. He's on the goalie. He's all alone. He goes backhand, forehand, backhand. Top shot. Woo! And he's selling. Woo! Oh, sorry about that. Didn't know I was rolling here. All right, back to my TED Talk here. We got 3 implications about water, you know. The implications about water, interesting, you know, worthwhile facts. Up to 60% of the human body is water. Like I was saying before, you know, it's kind of important a little bit, you know, and therefore we need it in order to survive. So yeah, we need water. Speaking of that, I gotta drink some. Oh. All right. Another implication is water is different than nearly all other substances on Earth because it expands rather than contracts when it freezes. So now that's a very interesting thing. So another thing, you know, it expands. So if you have a lake here, you know, pond where you're greasing some sticking pot, the water expands when it freezes, which allows it to, you know, float up to the surface. So you have a layer of ice on the top. Because, you know, this is very important because if we didn't have that, you know, if the water just froze from the bottom and started going up like that, like other substances, then all the living things in the lakes, you know, they would die because, like, you know, fish, they can't swim in ice, obviously. You know, they ain't like hockey players. They can't like skate, like glide gracefully around the ice. They need water to swim, so if without that, they would die. And, oh, it's been a fun time with you folks. Thanks for that beauty Owen over there for letting me take over his show. But now we got one last more important implication about water here. And that is that the hydrogen bonding within angular shape of water molecule makes a hexagonal structure, with open space in the center, which explains the water's low density. And this also has to do with water floating on, with ice floating on. Thank you for coming to my show today and showing for all your support. You know, hope to see you soon when all this Corona stuff gets away. And you know, I'm just gonna go back to being a beauty on the ice. No dangle snipe Sally. I'm out.